minus 4 cannot be 0. So you saw that you get x can't be 4. So it can be anything smaller than 4, it can be anything bigger than 4. So what is my interval? It can't be 4, so the 4 gets parentheses. Remember, parentheses is for not equal to. So b, it's a radical. I told you if it's a square root, it's whatever is underneath greater than or equal to 0. So 2x is greater than or equal to negative 5. So x is greater than or equal to negative 5 halves. So it's everything 5 halves and larger. Since it's equal to, the 5 halves gets a bracket. So bracket, negative 5 halves to infinity.
When did you say they can't be negative?
With the square root. So if it's like a square root, a fourth root, a sixth root, any of those can't be a negative underneath. So you just take whatever is underneath. If it can't be negative, it's got to be greater than or equal to 0. All right, C. Does it have a fraction? No. Does it have a square root? No. So I don't have anything to worry about. What does that mean my domain would be? D. It's a fraction. If I have a fraction, what do we know about the bottom? So 3x minus 4 cannot be 0. So 3x can't equal 4, so x can't be 4/3. So how do we write that? Questions there? Is it getting better? Okay, we're going to keep using this today, so we're going to keep practicing it. When we ended yesterday, we were talking about compositions. So in a composition, we saw something like f composed with g of x. And what that meant was we started with x, and which function did we plug it into first? G, okay? Then we get out that answer, and whatever that answer was, we plugged it into f, and that gave us the final answer, the composition. So a composition is just a way of doing a series of operations. The domain of these is a little more complicated. We still only have the 2 domain rules to worry about. But we have to look a couple different places to get our domain. If you look in your book, it has a really ugly description. So I'm going to ask I'm sure you guys go home and read your book to figure out how to do everything, okay? But if you do my way, it's a lot easier than what the book has you do, all right? So what we're going to do, we have to look at the final answer. Because obviously, whatever this is, if it's a fraction, we know the bottom can't be 0, okay? We also have to look at the original function. Then the overlap of these two give the domain. And I'm going to explain what I mean by that by looking at an example. So let's say I told you f of x is 1 over x, and g of x is 1 over x minus 2. Can you tell me, for their individual domains, what can x not be in this one? 0. What can I not put into this one? 2. So I know if I'm looking at them individually, it can't be 0 or 2. What if I asked for f composed with g? Alright, so if I actually did this composition, that means f of g of x. So g is 1 over x minus 2. And what do I have to do with that? I have to put it into f, right? So, if this were like f of 3, you would just replace your x with a 3. Since it's f of this whole thing, I'm going to f and I'm replacing my x with that whole thing. Alright, that's kind of ugly, isn't it? I don't really like a fraction in a fraction. Quick way to get rid of it. We have x minus 2 in the denominator here. So if we just multiply the top and the bottom by x minus 2, 1 times x minus 2 is x minus 2. 1 over x minus 2 times x minus 2. Those cancel and I get 1. So we just get x minus 2. If I asked you to look at the domain of this composition, it's really tempting to look right here. If I look right here, what does it say x can be? Anything, right? There's no fraction, no radical. Let's see if that's actually true. What happens if I asked you to do f of g of 0? Because we said originally f couldn't be 0, right? If I start with a 0 and put it into g, what do I get out? Negative 1/2. Can I plug negative 1/2 into f? Yeah, we get negative 2. So that wasn't a problem. What happens if I ask you to do f of g of 2? So if I try to plug a 2 in here, what happens? I get a 0 on the bottom. So when we're looking at the domain, we have to look at the final answer and this inside function. So I knew right here, as soon as I saw this, x couldn't be 2. When I got here, x could be anything. So when I put them together, my final domain is everything except 2. So it would be negative infinity to 2, union 2 to infinity. So for these compositions, you can't just look at the final answer. You also have to look at the inside, the first thing you plug in, and put the 2 together. Does that make sense? We're going to practice those, so please ask questions if you need to. I know you guys are more used to plugging numbers in rather than plugging a function into a function, so we're going to kind of practice that as well, getting those expressions and not just a nice pretty number answer. So let's say I gave you these two functions. Here's f of x and g of x. If I ask you to find the composition and the domain. So for A, this is f of g of x. So you start on the inside. What is g of x? I have to plug that into f. So f is something squared plus 3 times something minus 1. And I am replacing each of those with the 2x plus 3. So we're replacing each of those x's. All right. How do we do 2x plus 3 squared? Well, okay. So we get 4x squared plus 6x and plus 6x would be a 12x plus 9. This one we have to distribute the 3. So combine like terms and we get 4x squared plus 18x plus 17. That's my actual composition. Does everybody see how we got that? Second question I asked you was the domain. For the domain, you look 2 places. The inside, what we first plugged in, and the final answer. Okay, so if I look at what I first plugged in, did it have a fraction or a square root? No. What about my final answer? No. So we have absolutely nothing to worry about, so what's our domain? Why don't you guys try B? See if you can do G composed with F and its domain. Starting on the inside, f of x is x squared plus 3x minus 1. We are going to G and replacing our x with that. So then we get 2x squared plus 6x minus 2 plus 3. So 2x squared plus 6x plus 1. Did you guys get that part? Good. So, domain. We have to look at our final answer and this original inside function. Do we have any concerns there? No. So my domain is everything. Negative infinity, positive infinity. I know, wouldn't that be nice? Okay. Can we try another one?
Yes.
Let's do... Let's skip around. Yeah, let's do this one. All right, so again, I want to do each composition and its domain. So when I look at F composed with G, so F of G of X, start on the inside. So G of X is 3x. You have to put that into F, so it's the square root of whatever we plug in minus 1. So you just get the square root of 3x minus 1. You don't have to have parentheses around that 3x. Is that okay with everyone? So, talking about this domain, we look 2 places. When I look here, this original inside function, does the 3x cause any problems? No, it did not have a fraction, it did not have a square root. So as of right now, my domain could be anything. Then I have to look at the final answer. If you have a square root, what do you know? Can't be negative. So the thing under the radical greater than or equal to 0. So x has to be greater than or equal to 1/3. How would we write that in an interval? Yes. 1/3 gets a bracket because of the equal to. So it's 1/3 to positive. Yes. Yeah.
On this one, how come we only have 9 on the first one we did? It was like, we did 2 separate things. This one.
That one. Or are you talking about like what? The negative. Yeah, just that one.
So it can't be negative.
It's the x can be negative. It's just the whole expression can't be.
All right. So then if we go the other way, g of f of x. So f of x was the square root of x minus 1. So if I plug that into g, g is 3 times whatever we plug in. So it's just 3 times the square root of x minus 1. Okay, nothing we can do to simplify there. So that's my answer. Now the domain. Look 2 places. All right, so starting with this original one. It had a radical. So when I look at that, I know that the thing underneath had to be greater than or equal to 0, so x had to be greater than or equal to 1. When I look at my final answer, it again has a radical. So again, the x minus 1 is greater than or equal to 0, and x is greater than or equal to 1. So we had an issue with both of them, but this time they both gave us the same thing. So what's my final domain? How do we write it? 1 to infinity. Is this one okay? Let's try some more. Let's do one with some fractions. This time I'm only asking for f composed with g, so I'm not making you do both of them. So if I did f of g of x, so when I look at that, we start on the inside. G of x is 2 over x. When I plug that into f, f is 3 over whatever we put in minus 1. And the thing I'm putting in is 2 over x. Is everybody okay there? Now, what's wrong with that answer? Fraction and a fraction. That's bad notation. We're better at math than that, so we're not going to leave it like this. What's an easy way to get rid of it? What trick did I use before? Multiply by the denominator, which is just x on this one. So I'm just going to take everything times x. So if I do that, the top just becomes 3x. The bottom, 2 divided by x times x, would just be 2. Minus 1 times x is x. So I get this. So Now we need the domain. That's my composition. Domain. We look 2 places. The original inside. When I look right there, what do I notice? X cannot be 0. When I look down here at my final answer, the bottom, 2 minus x, cannot be 0. So if I solve that, add over my x, I get that 2 cannot equal x. So what we have here are 2 different numbers that x can't be. The interval notation for this is kind of ugly. So my general rule, if it's just one value x can't be, I want the interval notation. So if x only can't be 0, I want you to write negative infinity to 0, union 0 to infinity. If it's more than one value, I will allow you to just list them. So my final domain, x cannot be 0 or 2. And you can leave it like that. If you wanted to do the interval notation, just to kind of show you what it is, it's basically saying you have everything smaller than 0, everything between 0 and 2, and then everything bigger than 2. So it's actually 3 pieces. Negative infinity to 0, union 0 to 2, union 2 to infinity. So it gets kind of ugly, it adds extra pieces, and it's just a little cumbersome to write. So if it's more than one value, you can just tell me x cannot be these numbers. All right. How are we doing with domains? Is it better than yesterday? Mm-hmm. Okay, that was my goal. You guys just have to tell me if I'm doing, like, kind of assuming you've seen something and you haven't before. Okay. Do we need to do some more examples of this? You think you've got it? There's one last thing I want to cover today. It's pretty short, and then I'm going to give you guys time to work. So you can ask questions if you had any issues with yesterday's or today's. Okay? So the very last thing I want to do, I don't want to do that one. I have a lot of these here if we needed them. Tons and tons of them. Let's do this one. So I'm asking you to basically undo the composition. Find functions f and g such that f composed with g is equal to h if h of x equals this. Okay, so what this is saying is f composed with g gave me this for an answer. I composed them and this is what I got. Can you take this back apart and tell me what my original functions were? So, a lot of times there are multiple correct answers on this. I try to just go for the simplest. So when I look at this, g of x is on the inside, right? What is the inside over here? Or if you're going to plug in a number, what are you going to do first? You put, yeah, if I told you to plug in like a 5, you would put it in for the x, and then what calculation would you do? Would you start out doing 5 to the 4th? Yeah, you would take it, if I put in a 5, you would do 2 times 5 plus 3, get that answer and take it to the 4th, right? So the inside is where you start. So that's my g of x. So you could make it just the 2x. I like to just do the whole inside, like being the inside of my parenthesis. So my g of x, the inside function, the first thing you do could be 2x plus 3. All right, so let's think about this. When we do a composition, okay, if I say like f of x is x plus 1 and g of x is 4x, and I asked you to do f composed with g. you replace your g with the 4x, and then you go to the function f and you replace your x with that number, right? So where that 4x goes, you originally had just a plain x. So if we're going backwards, you just take whatever you used for your g and replace that with an x, and that's your function f. So f would be x to the 4th power. And it's easy to check them. You can do f composed with g and see if you get back the original problem. Let's try some more. So, f composed with g, so f of g of x is equal to 1 over x plus 1. I need to know what these functions are. So my inside is my g. That's what we do first. If you were going to plug a number in here, what would you do first? Add 1. Okay, so that's g, x plus 1. Then to get f, you basically replace that whole thing with an x. So f would just be 1 over x. You guys do this one. So, f of g is equal to this. So g is the inside. That's like the bottom of the fraction or the inside of the parenthesis. So when I look, g would have to be x squared plus 1. So f, if you took that out and replaced it with an x, you would just have x to the 50th power. All right, so this is my stopping point today. I am giving you another handout. It's a little bit shorter than yesterday's. Both of these will be collected tomorrow.